Hi, everyone. Welcome to the webinar. This webinar is Supercharge Legacy Data Platform with Azure Data Services. This is the third webinar in our Hadoop Azure migration webinar series. And we are super happy that Tarun Agarwal is able to present with us today. He is the data and AI lead here at MotiveWorks. So we're really lucky to have him share his expertise with you. And without further ado, Tarun, I'm going to turn it over to you.
Thanks, Sarah. Thank you very much. Hello, everyone. Good morning, good afternoon, good evening, depending on whichever part of the world you are joining this webinar today. I thank everybody to take time from their busy schedule to join this webinar. I hope you find something useful out of the webinar, and thanks for all the questions and response you are giving us on our series. It's really exciting to hear all the feedback and the type of questions we are getting. So before we start, just a quick background about myself. Like Sarah mentioned, I am the data and AI practice lead at MotiveWorks, and where we are helping our customers and clients to modernize data platform and force cost-effective cutting-edge technology solutions to leverage data as a strategic asset. Data plays a very important part and role in digital transformation, and by leveraging big data, cloud, we are enabling digital transformation in a lot of our customers' environment. In my background prior to MotiveWorks, I've been into various leadership positions, enabling data analytics solutions primarily for the financial services companies like Lincoln Financial, and prior to that, Deutsche Bank, Bank of America, and Barclays Capital. And I'm happy to share some of the expertise that I have and to enable doing big data analytics and creating modern data platforms in cloud. A brief introduction about who is MotiveWorks, what do we do, who we are. So we are a company which is born in cloud, and we always have a cloud first thinking. We are founded in Maryland, just outside Baltimore, and we are Microsoft partners, and we have acquired all the accreditations and credentials to be a trusted Microsoft Azure partner. We mainly work on helping customers to adopt cloud, whether they are looking cloud from a rehost, replatform, or re-architecture perspective. And I'll build cloud native applications using cloud native services, containers, Kubernetes, SaaS applications, mobile and web applications, and leverage the data platforms to enable data-driven organizations and also make them ready for machine learning and artificial intelligence. So, like we mentioned, we are running a series of webinars around doing big data analytics using Azure Data Services. Today's webinar is the third webinar in the series of 4, and we have already completed first 2 of them. If you were able to attend them, thank you very much for participation. I hope you were able to get something out of them. And if you could not attend for whatever reasons, please visit our website. You will be able to find link where you can be able to see those recorded webinars, which are now available as on-demand webinars. So today we'll be talking about how do we supercharge your legacy data platforms, whether it is data warehouse or data lakes, to run in Azure services at much faster performance and better optimized cost. Some of the agenda items that we will be looking at to understand what are some of the challenges of running your data warehouse and BI environments in on-premises, and people who are already moved and started to leverage data lake. Let's understand some of the benefits and challenges the data lake paradigm brings to the table, and then we'll talk about how can we improve and build a high-performing unified data platform in cloud to fulfill both the use cases, whether it's a data lake or data warehouse use cases. And then we'll end based on some of the best practices we need to implement a good data governance. All right, so jumping into the crux of the matter here. People and companies, organizations are building, and they have been building data warehouse and business intelligence environment for many, many decades. It's nothing new. I have done it for last 20 years. Some people have been doing it much longer than I have done it. So, and it has solved a lot of business problems, and it was good for whatever it was able to do. Typically, when we talk about a data warehousing and business intelligence environment, we have been mainly dealing with, and again, it's not fully, but mainly dealing with structured data, the data which is relational in nature, the data that generated within our own firewalls or even outside the firewalls, but structured data, like for example, CRM data coming out of Salesforce, right? So we have been building all these different data solutions by spinning up the data warehouse environment, and then there are multiple ways or multiple layers within data warehouse. We use word data warehouse very loosely and widely, but if you drill down into the details, we build staging layers, ODSs, enterprise data warehouse, specialized data marts, line of business focused warehouse like financial data warehouse or sales warehouse, different kinds of things we have been building. And we implement business intelligence layer on top of the warehouse layer we have built to really make all the data available to the business users for reporting and analysis. And to do all these things, to combine all the data that is generating from our relational systems or even other systems that we've integrated the data with, we have to implement complex ETL logic, pipelines and logics to really integrate all this data, to massage and scrub all this data, and to really create into a data model that is ready for downstream consumptions in reporting. The biggest challenge we have in this environment is everything is schematized, right? Every time we need to bring in something new in the reporting, which is not existing in our warehouse layer, we have to go through the entire identifying the data in the source system, doing the ETLs, bringing them into the warehouse, changing the warehouse schema to bring these new elements, putting them into aggregate layer, and then exposing it into the reporting. Everything was sequential, linear, and structured. It takes a lot of time to make all those changes, and that was actually slowing down the businesses, right? Small little changes requires weeks and months of effort before it is even available for even basic use. Other challenges that we face in this environment is heavy upfront investment is needed to make in the infrastructure. These ETL layers are complex, and monolithic applications and data warehouse are also very expensive investments. And because of the huge investments required, a lot of companies don't end up having high availability and disaster recovery environment, again, primarily because of the heavy investment which is needed. At the same time, as data continues to grow and we need to upgrade these systems, it requires another significant substantial investment. But still, from a business point of view, it is only giving them rear view mirror reporting. There's a descriptive analysis, what really happened in my organization. What were my sales? What was my regional sales, product sales, which sales team is doing the best? What is my top 10 clients? Still a lot of rear view reporting, and the forward-looking reporting like diagnostic analysis, why certain things happen, why did we lose customers, how many customers are likely to leave us, like what is going to be our churn rate, and what other actions can we take to prevent them from churning. These kind of questions were possible in a very limited fashion, and then a lot of time people end up creating their separate analytical sandbox to really get those things answered. And this whole time to market was becoming the main impediment to business growth. So that's really the challenge. And to solve these challenges, we started getting into this whole data lake paradigm, which was, let's bring all the data not only just the structured data that we are talking about, let's also bring on the unstructured data, or the data which is generating outside our firewall. Maybe data coming from system logs and web stream click streams from web logs and all those things. Let's analyze all of them by collecting them, storing them into a central lake, and analyzing them. That concept is really good, and it solves some of the challenges that the data warehouse technology was presenting. You do not have to wait for everything to be ready before you can start analyzing. As soon as you have stored, the data scientist and the data analyst starts to go into the lake and start analyzing the data. So time to market was becoming faster. We solved some of the challenges, and fundamentally, it was a right approach to look at how do we really we make our organization data driven. But it also brought some of its own challenges. The challenges of atomicity, right? When the data is coming, new data is coming in, how do we make sure that the people who are still reading the data, they are able to read the consistent data? And data consistency was becoming an issue. Data integrity was becoming a challenge, because as more and more people are using this data and bringing their own data sets into the lake, it was very hard to identify what is the right value, which one we should trust. And some of the other challenges that we have seen is, as we are appending the data, and people who are doing the reads, they are doing dirty read, they're getting dirty reads, the results are not consistent. If the data is frequently changing and we need to update or delete the data, that was a challenge in data lake kind of a solution. And then if the job which is running and it fails, then the data consistency becomes a question mark, and a lot of data gets corrupt, and you do not even know that there is a corrupt data unless somebody is doing some analysis and find the data is not right, and then we'll figure out that something happened, a job failed, and the data is not really correct. And then as more and more we add the data into the data lake, it adds more and more small file size, and throughput becomes challenging. Throughput starts becoming lower and lower. And by definition, data lake was to add more data in a small and then bring additional data. So small size is going to be a challenge, but data lake paradigm was not able to solve the throughput problem because of this. So those are some of the challenges people are running into when they run the legacy environment. And a lot of companies, what they have done is they actually coexist both data warehouse and data lake solution in their environment. So they have, for all their business intelligence and kind of reporting and analysis, they are still running their enterprise data warehouses or data marts. But in addition to that, they also create a data lake to enable their data scientists and data analysts to really start having early hands on the data. But fundamentally, the problems that these two systems create, they do not go away by coexisting. So it's not magically going to go away. So what can we do to solve these things? So it will be in an ideal world, if we can take the best out of data warehouse environment and the best out of data lake environment and combine both of them, that will be probably a good solution. So what would that solution will look like at a high level? If we get all the source data and store it and create a data lake from the data, and then we implement data warehouse solution on top of the data lake, that gives us a consistent results, and it also has all those data consistency and integrity intact, and then enable all your business intelligence, data machine learning scientists or data scientists leverage this data. So that will be an ideal world. But the challenge is, how do we build this? How do we combine the data lake paradigm with the existing data warehouse concepts and build this platform together? So that's where cloud technologies like Azure Cloud Platform comes in handy, and we can use Azure Cloud to build this unified cloud data platform. So fundamentally, let's start to understand from bottom up. By leveraging data ingestion tools and technologies, primarily with like Data Factory or Azure Databricks, we will be able to bring all our source data into the data lake store in Azure. So Azure Data Lake Store provides you the reliable and cost-effective place to bring in all your data and store it. It's very, very cost-effective, and you can bring in all your data, whether it's generating from your internal of within your firewalls and organization, or external data. If it is relational, non-relational, structured, unstructured, we can bring in into Azure Cloud Platform and store all the data into Data Lake Store. And we can use tools like Data Factory or Azure Databricks to do the ingestion part for it. But the data lake store is still just the storage layer, and we should not be starting to analyze the data right here. What will be really important from here is we build a structured transactional layer. So that's the layer that is actually gonna give you a structured layer, a schematized layer on top of the data which is sitting into files in data lake store, and keep it in an open format like Parquet, and allow you to query the data from this structured transaction layer. So using the Azure Databricks Delta Lake technology, we will be able to put this schematized transactional layer on top of the data lake store. The data is actually still sitting into your Azure Data Lake in file formats. It could be JSON files, CSV files, XML files, or any kind of file format, or text files. But we will be converting the data into relational format using the Delta technology. And nothing like in the last webinar, we talked about how data has various features that it allows you to create a robust transactional layer. We're talking about Delta Lake. So Delta Lake, first thing it will do is most important, it gives you the ACID transactional layer on top of your data lake. So by ACID, or what I mean by is atomicity, consistency, isolation, and durability. So because of having an ACID transactional layer, the same data which is sitting in your data lake store in a raw format, we will be able to create them into tables. So this will be raw data coming up into tabular form in a much compressed Parquet format into Delta Lake. And let's call it a bronze layer, which is basically still the raw data. Still the data as it coming from different systems into different files, but it is now available through a table format. So you can query this table, you can analyze this data, you can read the structure and the schema of the data in the bronze. From there, we will start to build our data lake using the Delta technology. The next thing we will do is we will try to cleanse and massage the data by removing like the things like null values and duplicate values, and doing the deduplication or joining them with some other reference data to create a better structure, and that will be called as a silver layer. So we take our bronze layer and massage the data and create silver layer, and from silver layer we will create like the business related subject areas, or call it aggregate tables, or the data mart dimensional schema into gold layer, which will give you the business related aggregated data that can be queried for various reporting and analysis purposes. And each of these things is really using and leveraging the Databricks Delta engine and the Databricks runtime behind the scene. And last time, if you recall, we talked about some of the benefits of having this Delta engine, which gives you a very high performing Spark engine behind the scene. Delta is a structured transaction layer, so SQL really works here. But people who are Python programmer or Scala programmer, they can also work here and able to run and leverage the Spark technology to process this data. It gives you the parallelism to run using the Spark technology, the in-memory parallel data sets, and which you can create in part as a part of your data frame. And it will allow you to cache the data. It can partition the data and then give you the high performance by using concepts like data skipping and Z-order clustering we talked about last time. So using this, we will be able to create all our transactional layer of cleansing, massaging, and creating the certified data sets in a gold layer. So if you really think about it, what really changed is all that massive ETL things that we were doing in our legacy system, we are now leveraging the Spark-based Databricks technology for the data processing engine, which is giving you high performance and all this consistent data into this. Then from here, we can build our data warehouse layer. So the gold layer already has the business facing certified data that is pre-aggregated for reporting analytics kind of use case. We can copy this gold layer into data warehouse technology, and in Azure world, if we are talking about large data sets in a big data environment, it will be Synapse Analytics. So we can copy the gold layer of Delta Lake into Synapse Analytics. We're just copying it and make it available for downstream consumptions, which could be reporting using Power BI, it could be analysis using Azure Analysis Services, and it gives dashboarding kind of features to the business users. And Azure Databricks already makes you available to perform all your machine learning kind of analytics using Azure Databricks ML Flow engine that we reviewed last time. In addition to that, it also works very seamlessly with Azure machine learning tools. So it gives you the ability to query the data for predictive analytics or machine learning use case by going against any of the three layers, whether it is bronze, silver, and gold. A lot of time we have seen that data scientists wants to get their hands early to the data, so they will be leveraging the bronze layer. But the key part here is people do not need to tap into the data lake, Azure Data Lake store. Everything which is in the Azure Data Lake store is available through the Delta Lake technology as a part of, in the form of tables. So whether it's a data scientist, data analyst, data engineer, everybody will be able to access the data from these Delta Lake tables, which is in the three different logical layers available. And then it gives you the ability to do all your machine learning, business intelligence, reporting, analytics, all different kinds of use cases. Synapse Analytics, if we have not talked more about it, it's a relational MPP data warehouse engine, which is powered by Microsoft Azure Cloud. It is optimized to run enterprise data warehouses and big data analytics. It can handle petabytes of data, and it gives you a lot of horsepower, whether you want to run it in an on-demand SQL on-demand engine or serverless engine. It has both the capabilities, and you will be able to run very high-performing optimized queries against Synapse Analytics engine. And it is a relational engine, so all your T-SQL-like queries, the data, BI queries, they all can work seamlessly against this layer. So just to summarize, what are the benefits of building this modern architecture using Azure Data Services? We will be able to bring in the asset compliance layer on top of the data lake. So the challenges we talked about in the earlier slides about when we are trying to append and ingest the data into data lake, the people who are trying to read the data, they get the dirty reads and the accuracy of the data is questionable. So we will overcome this problem by having the asset transaction layer on top of our data. So users will be querying the data coming from silver layer, and they will get consistent results even though the data is being ingested in the data lake as they are querying. Frequent data modifications like updates and deletes, because it's providing you the transactional layer. It will be easily possible to modify the data into Delta Lake tables, and that problem goes away using this technology. If job fails, and it happens all the time in every environment, typically many jobs fail for various different reasons. So even if the job fails, Delta Lake technology will not commit the failed data records, and the old data before the job will still be impacted. So people will still get consistent data, and the failed jobs can be rerun without impacting or doing any data cleansing needed because of the failed job. And because of asset transactions layer, it also allows you to combine your batch data with streaming data. I know we did not talk about streaming use case, but if there are use case where data is, in addition to the nightly batch jobs, data is also coming in real time. The challenge of data lake of combining them into one data set, it can be overcome using this asset technology of Delta Lake. And then it provides you the version control of the data and gives you the data governance and auditing capabilities. So we will know what is the last data that was updated in these Delta Lake tables, and if what was a failed job that is not available. All of those governance and versioning is available through Delta Lake. We talked about Delta Lake engine. It gives you a very high SQL processing engine. It gives you schema validation, so everything is available through table structures. So the data is going to be validated with the schema of the table before we start having problems of schema on read kind of problems. And Delta Lake allows to partition the data, and we talked about the partitioning the data and then leveraging the partitioning for data skipping purposes, and then creating multi-dimensional formats of the data, say in the data files, using the G-order technology that is allow you to achieve 10x to 20x, even more performance optimization using Delta Lake engine. And then we talked about auto compaction that takes care of the small file problems that we saw earlier on with data lake technology. It will automatically compact the small files into larger files and optimize the throughput of the environment. We talked about the Synapse Analytics, which allows you to do petabytes of data analytics at scale using the MPP architecture, and it gives you the full T-SQL query. So all your SQL developers and the BI developers can still work in Synapse Analytics technology. And it gives you a limitless scale, whether you are going for SQL on-demand engine versus serverless engine. So we talked about building a unified platform which combines data lake and the data warehouse together and creates this unified platform. But still, a lot of companies are running traditional data warehouses, which is enterprise data warehouses or data marts, which is still only dealing with structured data, and they still have all those problems of creating bringing in new data element by going through the entire ETL process and upgrading the environment in case data size increases, and having multiple environments for high availability disaster recovery. All those are still a challenge in a relational data warehouse environment. So how can Azure Cloud help? Even if we were not ready, we do not have a use case for building a data lake kind of a unified environment, we can still bring in our legacy data warehouses running on premises into the cloud and use Synapse Analytics. That the Synapse Analytics alone is going to give you like a petabyte scale capacity to run at a fast performance and very optimized cost. And ingestion tools like Azure Data Factory will allow you to copy data from on-premises databases or OLTP databases or files, where whatever it's generate, copy data into Azure environment and build your data warehouse models into Synapse and expose it through Power BI. If you still want to keep some raw format for storage purposes, for auditing purposes, we can leverage, we do not have to keep that in Synapse and pay higher cost. We can still leverage Azure Data Lake Store as a cost-effective way of storing our data. And we can, Azure Synapse Analytics has a poly-based technology. It can, using poly-based technology, we can ingest the data sitting into Azure Data Lake Store into Synapse Analytics as and when needed. So this is a case study that we have worked on and helped an online food company to optimize their data warehouse and business intelligence environment. They were running their data warehouse using Oracle technology, and because of the high Oracle licensing costs, they did not have multiple environments and did not have high availability and disaster recovery for failover purposes. And they were looking to create a high availability disaster recovery environment, but also save on the cost. At the same time, increase their speed to market for all the new changes that happens. So we were able to migrate and lift and shift their Oracle warehouse using into Synapse Analytics technology. Back then it was called SQL DW, so it's a SQL data warehouse technology. Their entire ETL logic was running into SAP data services. So we were able to lift and shift that and run into Azure using VM technologies. But eventually we will be converting them into Azure Data Factory pipelines and trying to populate the Synapse technology directly using their pipelines and copying data. Their current ETL, all the BI technology is running into business objects, which was moved into Azure platform as it is. And using this architecture, we were able to save 61% of the cost of running their entire BI data warehouse and BI environment into Azure and give them better performance and higher throughputs. So a word around how do we manage and govern this platform. So I think we talked about multiple different layers. I think we talked about bringing all your data into data lake, exposing the raw data as a bronze layer, and then creating and massaging the data into silver layer, then creating business ready data sets using gold layer, and then Synapse Analytics becomes your data warehouse layer. And then we talked about analysis services, Power BI, machine learning, different kinds of use case. So how do we govern and what kind of security and access we need? So it's very important that we start implementing some kind of data governance at organization if we really want to have a robust, scalable environment that is going to drive your businesses forward. And depending on various different roles, we should think about who needs to what level of access. And it's more than the access. We'll talk about some of the data governance. It's about what data is available for what different kind of purposes. How do we classify the data? How do we tag the data? And which data is restricted? Which data is available to everybody? And who can access to have what kind of access on what kind of data set? It's all part of the data governance. But if you look at from an access and security point of view, data engineers who are really responsible for building this entire platform, they will be able to have access on all the different layers so that they can populate data from as it comes in all the way into the reporting layer. Data scientists are the guys who needs their hands on as early as possible. They will have access to all the way from bronze layer until anywhere else we are creating the different data sets. They do not need to access data lake directly because data lake data is already exposed through the bronze layer as it is. So they do not need access directly on data lake. They will be able to access it through the delta lake bronze layers. Data analysts who will be analyzing this data, and they also need their hands as early as possible. They can go. They do not need the bronze layer because that has a raw data. Still, it requires a lot of cleansing that data scientists can do. But for data analysts, they should start leveraging from silver layer onwards, so that they can use it for their different kind of analysis. Business users, the SMEs of the business, who are the data owners, they don't need anything in the Delta Lake technology because it's still used as a data processing engine. They should be able to go against the data warehouse layer and able to analyze their data, and then definitely they will have access to the reporting side. Business users, they do not even need direct access to data warehouse. They can get all their data needs fulfilled through the reporting and analysis layer in analysis services and Power BI. And the data consumers who are just going to be consuming some periodic reports, they will be accessing only the Power BI layer. So using this, we can govern the security and access. But as I was talking about, the data governance is a broader topic, not just security and access. Really, to have a robust implementation, we should think about identifying the owners, depending on what the subject area is, whether we are talking about sales data or finance data or marketing data. We need to identify who are the owners of this data. Within those owners, who are the decision makers who will decide what is the right data to use and which data is certified, which is trusted data, versus who are the data stewards who will be deciding and on the different things, different kind of anomalies or different things happening, and making a recommendation to the data owners for the final decision, and then implement different standards of classifying the data and identifying which data sources should be leveraged, which are not the right data sources, and what data takes precedence over other. define some standards, catalog all your data sources, whether it's coming as the data is coming in. We should start to catalog so we understand each data set. What does it mean? What kind of schema it has? What kind of each individual columns have all the different profiling of the data, and that can use to measure the quality, and then implement some access controls using the security layer. And in the data quality, as we are measuring, the data stewards and data owners will be able to help us improve the quality by making certain decisions about by establishing the standards. And then we can think about merging the different catalogs and creating master records, master data, or the reference data, and that can be used to populate our data repositories. So using this kind of technique, it's a iterative technique, agile way of implementing data governance. There are, I think, Azure Data Catalog is a good starting point for people who are trying to build their data platforms in Azure to leverage data catalog to catalog and create schemas of all their data sources so that they can profile and create standards. So there are still a great starting point, and there are other tools and technologies available in marketplace in Azure that can be leveraged to really implement this as a robust data governance principle by leveraging agile technology methodologies. Okay, so that's pretty much I wanted to discuss around how do we supercharge our legacy environments using Azure Cloud Platform. To summarize, using this Azure Cloud Platform, we can have the first and foremost problem of we can have the fast turnaround time. The changes into your data warehouse environment that used to take weeks or months can now become complete in days or weeks now. We can combine the batch data and the streaming data that is coming in real time to have a unified reporting from and not have to worry about doing separate data silos. The asset transaction layer is going to give you the data consistency, reliability, and integrity to use your data with confidence and really trust your data. And the cloud platform is going to give you the scalability, flexibility, and speed. You do not need to guess your infrastructure need or how much sizing you need to do for your warehouse environment. You can start small, and then with a click of few buttons, you can scale as up as or down as needed, and you do not need to spend a lot of time and energy to guesstimate your sizing. Because of the cloud platform, all of these services are cloud native platform as a service offers, where the app dev team do not have to focus on managing and maintaining the infrastructure. They can focus on driving the business value by delivering the ROI. Businesses will become data driven. They can get access to the data as early as possible, and they can use data to drive their businesses forward. And it will bring in innovation because it's making the data available for machine learning, prescriptive analytics, predictive analytics, artificial intelligence, these kind of use cases. All right, so I think quickly going over some of the solutions Motiveworks provide to help you achieve and build all these unified cloud platform using Azure technology. We have Azure Smart Databricks Solution Accelerator, where we can build your data platform using Databricks technology and allow you to gain up to 100x by re-architecting your applications, or by up to 10 to 20x by running your applications using your legacy technology using Databricks data processing engine, and gives you an optimized cost and with better reliable systems. We also have an offer where we help you migrate your current analytical workloads into Azure Cloud, which will make it faster and cheaper, and try to see if you can be eligible for additional cost savings by running your enterprise assurance and software assurance and enterprise agreements in bringing them into Azure Cloud. We also have our big data offer. I think we have been talking about it. If you are running your Hadoop big data workloads and you are interested in moving them into Azure Cloud and get benefit of better performance and cost optimization of running those workloads in Azure, we can help you do a technical assessment in a 2-day workshop, and also help you migrate your data from your on-premises Hadoop Lake into Azure Data Lake Store. And finally, we have a cost savings calculator at our website. If you go to motiveworks.com, you will be able to find Azure Big Data Cost Saving Calculator, whereby providing some of your key sizing of your existing Hadoop workloads, like number of nodes and number of jobs you run today, you will be able to get estimated or projected cost savings of running those same workloads into Azure Cloud. And this is a sample of a workload where we saved 62% of cost by running them into Azure. So that brings to us the conclusion of our third webinar. And like I mentioned, we have one more to go, which is a week from today at the same time, which we are talking about how do we, and the different approaches we have to migrate the Hadoop data into Azure Cloud. And please join this exciting webinar to see how can you migrate your Hadoop workloads into cloud. So I'll hand it over back to Sarah to see if there are any questions we can take.
Thank you so much, Tarun. And thank you everyone for attending, for engaging. We're really happy that you guys are able to attend these webinars, and that you're able to hopefully learn something from these. So at this point, I'm going to open it up for questions and answers. If you can just type your question into the chat box that you'll see on your screen, I will read the question to Tarun and he will answer. And, you know, like always, as it says on the screen, if you think of a question at a later date and you know, need an answer, feel free to email Tarun at the email address listed on the screen. All right, so we do have one question. It says, can we connect Power BI reports to Delta table for reporting needs?
Can we connect Power BI to Delta tables? The short answer is yes, you can, but I would not recommend it. Power BI is a reporting analysis layer. I think the performance of running your Power BI workloads off of Delta table is not going to be optimized, and you're not going to get that kind of performance that otherwise you need from a tool like Power BI. So I would recommend you to use your Delta gold layer that is copied into the data warehouse environment like Synapse to go Power BI against Synapse and use it from there. So I would not recommend against Delta tables, even though it's possible.
Great, thank you, Tarun. Next question, what is the difference between the silver and gold data in Data Lake versus storing data in Delta Lake?
What is the difference between silver and gold versus storing data into Delta Lake? So silver, thank you for the question. Silver and gold data layers, I think I briefly mentioned it. They are like logical layers. They are not any new technology or physical separation. They're just as you are transforming and processing your data from the raw data that you got into your data lake, which is stored into Azure Data Lake Store. You massage and cleanse that into silver, and then further combine that data with your other business reference data to create aggregated data. So it's just a logical data concepts that I explained to you from so that you understand how do we build from one step to another. Otherwise there's no difference. Thank you for the question.
Thank you. Next question, will Synapse and Databricks work from the same Delta Lake data?
Will Synapse and Data? Yes, I think we talked about, I think just before that, the gold tables, the tables in the gold layer of Delta Lake in Databricks will be copied into Synapse. So yeah, it's actually working from the same tables in gold layer, both Databricks and Synapse. And that's the beauty of these solutions, is they are unified. You do not need to create data silos.
Great, thank you, Tarun, and thank you for the question. We have time for just one more question, so I'm gonna give you guys a second. If you have any other questions, feel free to type it into the box. All right, last question. Can ADF convert to Delta format directly without Databricks or Spark?
Can ADF, Azure Data Factory? Almost. Thank you for the question. I think you got me here. It is not ready. So Azure Data Factory will not be able to directly copy the data into Delta Lake tables as of now. I think that is one of the features which Microsoft is working as we speak. So hopefully sometime in future it will be available, but as of now, the Data Factory will be able to copy the data into Data Lake store, and from there, using Databricks, we will be able to create them as a Delta table. Thank you for the question. Hopefully, it will be ready in the future.
Great, thank you, Tarun.
But I think just to add one more thing here, Sarah, there are other tools available out there in the marketplace which can copy the data directly into data tables as it is loading the data into Data Lake.
Okay, great, Tarun. Thank you so much. So we are pretty much out of time. So if you guys have any other questions, please email Tarun at the email address listed on the screen, and he will get back to you as soon as possible. You can also find out more information about all of our services, all things data, on our website, www.motiveworks.com. And I hope to see all of you at the next webinar. Thank you so much for attending. Thank you, Tarun.
Thank you, Sarah, for being nice host.